Okay, everybody. Here we go, solving proportions. Now we got to be quick. I know I've got 1, 2, 3, 4, 5 pages of stuff on here, so we can't dilly-dally around. But here's what we got going on today. Solving proportions. Remember, we solved those proportional equations what seems like forever and ago last week. And so those proportional equations will help us solve problems like 1 through 4 that we see on here. And so I'll show you my trick to hopefully do this. Basically, we create a proportional equation and then we solve it just like we did. It doesn't matter if I have decimals or fractions in that proportional equations, we still cross multiply and solve. All right, so here's what we know. 1/4 of a race is 1/8 of a mile long. How long is the race? Okay, well, here's how we make our proportion. I would say we come up with our two variables, basically. One of them is, I don't even know a good way to call this. Let's just say, oops, let's move over here. There we go. So we're going to say race length and, I don't know, distance. This isn't a very good one to start off with, but just hang with me. If the race is 1/4, the distance is 1/8. I struggle to write a fraction. Oh my goodness. Let's get rid of that. Go. Okay. Try again. So if 1/4 of the race is 1/8, okay, I want to know how much a whole race is. Well, a whole race is 1 over x. So you can't even see this now, but here's what it looks like. 1/4, right, and 1/8. You can change these into decimals if you so like, is 1 over x. So cross multiply and solve, right? Cross multiply. So I get 1/4 x equals 1/8. Okay. Remember what we would do here. Take 1/8 and divide it by 1/4. So divide by 0.25. Look at that. I'm switching up. Divide by 0.25. When we do this, 1/8, remember with division, order makes a difference. 1/8 divided by 1/4 is just a half. There you go. So number 1, my answer is 1/2. Okay. Let's try number 2 over here. 1/3 of a bottle of water fills 1/6 of a fish tank. So I'm going to compare two things. How much the bottle fills in the fish tank. So 1/3 fills up 1/6 of it. And then it says how much water is needed to fill a whole tank. So here's where you got to figure out where does my 1 go. Do I want to know how much one bottle will fill up? No. I want to know an entire fish tank, right? That's 1. Cross multiply and solve. So this is 1/6 x equals 1/3. Figure it out the same way. Take 1/3. So then we divide by 1/6. So it's really 1/3 divided by 1/6. That's what this will be equal to. So 1/3 divided by 1/6 is the awesomest whole number 2. So number 2 is 2. Okay. Number 4, 5/6 of a mile is 1/3 of the drive to school. How far is the drive to school? Okay. Let me just zoom in a little bit over here. So 1/3 of the drive to school is 5/6 of a mile. How far to the drive is school? So you could have 5/6, right, is just 1/3 of the drive. Right? How far is the drive to school? Remember, drive is 1/3. So I want to know the total the entire, so that's 1. Right, and it looks like this. Again, cross multiply and solve. So 1/3 x equals this 5/6. Ooh, I can't even talk today. Again, how do I solve this? They're fractions, but don't worry about it. Take 5/6, right? 5/6, and divide that by 1/3. All right, we get, I think, 2.5. So 2.5. If you don't know how to put fractions in on a calculator, just ask any of your classmates who are doing pretty good. I'm going to let you ladies handle number 3 while I chit-chat to you about 5 and 6 really quickly. So 5, do the numbers in the table represent a proportional relationship? If so, explain. So do the numbers in the table, oh boy. 7th grade math, maybe you remember y equals kx, all right? This is our proportional equation, right? And then we'd say, hey, y equals 2x, or y equals a half x, or whatever. Well, we can also say, we can figure out the constant of proportionality, k, if we take y and divide it by x. So if we do that in our table right here, we should get the same number every time if it's proportional. So in other words, what I mean by that is take 6 and divide that by 1. Well, that would equal 6. Take 12, divide that by 2, 6. 18 divided by 3, yep. 24 divided by 4, 6. So is this one proportional? Yes. My constant of proportionality would be 6, and if I wrote an equation for it, it would look like y equals 6x. Now remember, all of these have to be 6. As soon as I get one of these that's like 5 or 4.5 or 7, then it's not proportional. What about number 6? Again, maybe do some division here. 4 divided by 1 is 4. 6 divided by 3, 2. 9 divided by 5. I can stop right now. Because look, 4 and 2, 9 divided by 5, what is that? That's 1 and 1.8. All right, this one not proportional. No, right? When I take y divided by x, I don't get the same number. Oh, that's how those go. That's right. I will let you handle 7 through 10. Let's look over here at 11 and 12. If you are a graph of a proportional relationship, you do 2 things and 2 things only. You're a straight line and you go through the origin. Okay? But that's not what this wants to know, though, so that's great. Identify the constant of proportionality. Again, y over x. Y over x. So constant of proportionality says y divided by x. So take this first point here. This would be the ordered pair what? 4, 6. Okay. Next blue dot is the ordered pair 8, 12. Think about those tables that we just had a second ago, right? Here's an x value, here's a y value. Look, we just made a table. Y divided by x. Y divided by x. So this would be 6 divided by 4. What is that? 1.5. Does 12 divided by 8 give me the same thing? 12 divided by 8. Yep, it sure does. 1 and 1/2. All right, so identify the constant of proportionality. Constant of proportionality is just 1.5. If we were going to write an equation, it'd look like this. Y equals 1.5x. Or you could say 1 and 1/2, like a mixed number. Okie dokie. Don't worry, you're in direct competition with the boys. When I get back on Wednesday and Thursday, we'll have our little running competition. It should be a 2-dayer, so we should have some fun. So make sure you're doing well on these. We've got more. Does this table represent a proportional relationship? Again, y divided by x to solve 17 and 18. 15 and 16, what does the point 12, 18 indicate? So 1218 is this point right here. What does that mean? That means 12 pounds cost 18 bucks. Right? That's exactly what that means. I'll let you figure out number 16. What do these questions up here want to know? What does the highlighted ordered pair indicate? All right, so this would be the ordered pair. Let me switch over to writing here. 4, 28. What does that mean? That means for every 4 of these, we end up paying $28, right? Or in this case, well, this shows us clearly not a proportional relationship, because if we purchase 4 pairs of jeans, they cost us $28. No, this is good. I take it back. I take it all back. It looks like our constant of proportionality is $7. So for every one of these I buy, this goes up 7. All right. Let's see. What else do I need to give you before I turn you loose? I'll do a couple more proportional equations for you here. So let's take a look at 19. So we're talking about cookies and sugar, and that sounds like fun. It says each batch of cookies requires 2.5 cups of sugar. Write an equation that represents, oh, this isn't any fun, the number of cups needed for batches. Well, that's boring. So every one batch of cookies takes 2.5 of these. So one batch of cookies needs 2.5 cups of sugar. So write an equation that represents the number of cups needed. So that means cups needed for every batch. So you would say y equals 2.5 b. So if you want to make one batch, then you need 2.5 cups. If you want to make 2 batches, you need 2.5 times 2. All right. Sorry, I put a y on here. Forget that there was ever a y here. Make this a c. There you go. So cups of sugar is equal to 2.5 times b. Right? If you want to make one batch, 2.5 times 1. You want to make 3 batches, 2.5 times 3. Let's look at, finally, here we go. Question 21. Brandy needs 1/4 of a teaspoon of vanilla extract to make 2 dozen cookies. How many teaspoons will she need to make 5.5 dozen cookies? Okay, so vanilla to cookies, right? This is more of a better example to make a proportion. So 1/4, you know what? Let's do decimals for crying out loud. 1/4 of vanilla gets you how many cookies? Gets you 2 dozen. If you want to put a 2 there, you can. If you want to change it to 24, you could. Okay? I want to know how much vanilla I need to make 5.5 dozen. So 5.5 x. Here we go. Cross multiply and solve. 2x equals, we've got to do what? 1/4 times 5.5. That's a weird number here, 1.375. What is that, 1 3/8? Divide by 2. Divide by 2. Again, what is my answer going to be? My answer is going to tell me how many or how much I need in teaspoons of vanilla extract. So 1.325 divided by 2. So this is 0.6875. If you have math skills like me, you would realize that that is 11/16 of a teaspoon. Boom. Let's see. 23, just a blast from the past there on percents. Nothing new there. Nor is 24. Yeah, I think you guys should be good. So We got some percent air and stuff like that. So that's percents, right? Work through those. Whew, I ate up 15 minutes. So rewatch this. If you need help on one of these parts, rewatch it. If not, have a awesome day. Solve the rest of these when you're done. Give it. I think Mr. Trissel is going to be our sub again. So hand it to Mr. Trissel. Give him a high five for being a Hall of Famer. And you guys have a great day. See you.